Okay, so we're going to start with some terms today. Some of this should be familiar to you, some of it not so familiar. So let's start with the actual definition for a circle. So a circle is a set of points equidistant from a given, that's an O, point called the center. And then in our case, we're going to call the center of our circle, circle P. So the center is always labeled with a capital letter, so it can't be a lowercase letter. Danny, do you need to move forward so you can see today? Oh, you do? Okay, perfect. So your new notation for a circle, it looks like a circle with a hole in the middle and then a capital P. So this circle is going to have a hole in the center, as close to center as I can get it, P. So that's called circle P. And if you sat in the middle, well, if you sat somewhere and held a rope and just above your head and just started swinging the rope like this, where your head's considered the center of the circle, and just swung the rope like this, wouldn't you be creating a circle? Because that rope acts as a radius, doesn't it? And so the points on that circle are all equal distance from the center. What's a radius? What's radius? That. It's a what? It's not half of a circle. That would be a semicircle. From the center to the outside of the circle. So here's your actual definition. So the radius is a segment with endpoints at the center and on the circle. The radius is always half the diameter, and I think that's what some of you were trying to say. And so radius would go from point P to, oh, I don't know, here, point A. And then you connect with a straight edge. I can't on here, but that it's a little squiggly. That's your radius. Do you know what a chord is? All the way back to 7th grade math. What's a chord of the circle? It's not something you sing. Nobody knows. Nobody has an idea.
Is it like one side to the other side without crossing the middle?
One side to the other side without crossing the middle. Almost true. It does have its endpoints on either side of the circle, so it intersects the circle in two places, but it can go through the center. So a diameter can be a chord. In fact, the diameter is the largest chord in the circle. So the true definition of a chord is a segment. Oh, gracious, what the heck happened there? Oh, you know why? I must have chosen my highlighter. Let's try this. That was really fun. A segment with endpoints on the circle. And you might want to put in here the diameter is the longest chord. Oh, having trouble writing today. And so here's our circle P. And then we're going to put J here and K here, just kidding, but not really, and connect those, that becomes your chord. With a straight edge, you're going to connect that. That thing hanging around your neck is a wonderful straight edge. So now what's the diameter? What's the diameter? It's a chord that goes to the center of the circle, right? So your diameter, no, let's do that in orange. Your diameter is a chord that passes through the center. It is always twice the radius. So here's our circle P, and then here's A, and here's, I don't know, B, put B over here. So your diameter hits the center of the circle and touches two sides of the circle in a straight line. So it's a chord that contains that center. Anybody know what a secant is?
Is that something that just like touches the outside of the circle?
Nope, that's your tangent. That's your tangent. So a secant is a line that intersects the circle in two places. So the difference between a secant and a chord is a secant's a line, a chord's a line segment on that secant. So a secant contains a chord. So the true definition for your secant is going to be a line that intersects the circle in exactly two places. Contains a chord. So if this is circle P, a secant might be here at C going through D. So it's going to be a line. Let me erase C and D so I don't hit them with my line. So let's put C here and D here. So there's your secant. A secant can go through the center of the circle, but then it would contain the diameter. It's still a secant. So as long as it's a line that intersects the circle in two places. So then as Andre was talking, the tangent is similar to a secant, except a tangent only intersects the circle in one place. And what that does is it just kisses the circle. It just touches the outside of the circle. It doesn't actually go through the interior of the circle. So the definition of a tangent is going to be, oh, no, we've already had that one. Let's do brown. So a tangent is also a line.
If it's a line that goes through the circle, like the center, like the,
If it's a line that goes through the center of the circle, like it contains the diameter, that's still a secant.
it's still,
Because it's still intersecting the circle in two places. And that's really the crux of that definition. So are we good with that? Okay. So tangent is a line that intersects the circle in exactly one place. you might put in here kisses. And that's a technical word, the circle. So here's circle P. And so a tangent line, oops, I just missed it, but I'm going to fix it here. Tangent line would touch the circle right here. And we're going to call that point Q. And then this would be R out here, and maybe S here. So the point at which it is touching, this point right here, this point is your point of tangency. So that point at which it touches the circle becomes our point of tangency. And so it becomes very important. We do a lot with it. Yes.
Is it like a line segment, or is it a line? Does
It's
it
a
keep
line.
going on, or
It actually can be part of a line, and you'll see in a
2 points at the end?
right. So long as it's outside the circle, and it, like if you went just from Q to S, that would be considered a tangent line,
Right.
even though it's a segment.
So it could
It's
be a
part of a
segment or
line.
a line?
Yeah. And the secant could be a segment. You'll see some examples on the one of the pages that I gave you in just a minute. All right, so the last thing that we're going to look at is the point of tangency. And let's do pink. So your point of tangency is the point at which a tangent line intersects a circle. So again, we're going to use the same picture as above. Here's circle P. Here's Q, our point of tangency, our tangent line. And then this would be R, and this would be S. So in this case, Q right here, that is your point of tangency.
So one's the actual line and then one's the point.
Right, so the tangent's your line, the point of tangency is the place at which that tangent line touches the circle. So any questions on these definitions here? Okay. All right, so let's turn to our next, which are parts of a circle. So you are only going to do, whoops, not that. So you are going to do questions, well, let's go ahead and circle the parts of the circle you're responsible for today. We're going to come back to this page and do the rest of the parts, and the rest of the definitions are on the back of the first page that we looked at. But for right now, I only want you focusing on these ones today, because these are the ones we're talking about. So as far as I'm concerned, you're going to do questions. Oh, let me pull my paper out. Have I lost it already? You are going to look at questions 1. Oh, that's not going to work. Try this. How about question 1, 7, 11, 19, 2, 4, 6, 10, 12, and 18. So I want you to answer those. Use the parts of the circle that are above and answer those questions using those parts of the circle all by yourself. And then we'll meet as a whole group here in a minute. All right, so let's look at some of these, because some of these are difficult. A few of them are difficult. So as we look at LQ, so from L to Q, what's going on here? What do you think that is? L to Q. Is it outside the circle or inside the circle? Outside. Touches the circle once. What is it? I know it's not a line, but it is part of a line, isn't it? Right? So even though it's a chord, it's still considered a tangent. So that's a tangent. What about PN? So from P to N, what is that? A radius. So that was easy, right? While we're at it, we're going to do 2, 4, and 6. So what is WY? A chord. It's fully inside the circle, and it only touches the circle twice, right? So that's a chord. What about just the point X? Center. Good. What about line ST? Where is it? Where is it? From S to T. It is outside the circle, right? And it is only touching the circle in one place right here. What's R called? The point of tangency. So this line ST is a tangent line. So it's tangent to the circle. And then, let's move this up. Let's look at number 10, QN. So from Q to N is what? A diameter. Good. What about, can I see the whole thing? Nope. What about U to Y? So it is a line that is extending outside the circle, correct? So this is not a chord because UY itself would be a chord if it were just the line segment UY. But because they have the notation above here that shows that it's the line, if it were just a line segment above there, it would be a chord. But because the notation says line, it is definitely a secant. And it intersects that circle twice. And then point R we already said was a point of tangency, didn't we? So 18 is line segment LN. So as we look at LN, where is it? From L to N. I know it's not a line, but doesn't it extend outside the circle? So since it extends outside the circle, how many places does this line segment touch the circle? Twice. Because it touches the circle in 2 places, it is a secant. It is not a chord, because a chord does not extend outside the circle. So, whoops, let's move it down. So that was LN, right? So LN is a secant. So the last one is line segment UX. So look back up here at UX. So from U to X, what is that? Easy, right? Radius. So our last one is radius. Any questions on any of those that we talked about? Are we good? Okay. So let's go to the next page. So these are your actual notes. So our topic today is, aside from knowing the parts of a circle, would be area and circumference. I'm calling your notes 10-1. We are skipping chapter 9 momentarily and going on to chapter 10. We'll come back to chapter 9 before spring break. Again, let's rewrite our area formulas here. So we've got area is equal to pi r squared, where r is your radius. And then we had the 2 circumference formulas. Circumference is equal to 2 pi r, or circumference is equal to pi d, where r is your radius and d equals your diameter. Why the 2 formulas here? What's 2 times r equal to? D. So I will use this formula when they give me diameter. It's real easy, just tack pi onto it. I will use this formula when they give me radius, because I'm going to have to multiply the radius by 2 anyway if I'm going to use this one. So why not just use this one? There is only one formula for area. So let's go ahead and look at a few of formulas. Formulas for you, I feel, are review. So the directions here say that we are going to do for questions 1 through 4 area and for 5 through 8 circumference. Well, we're not going to do, we might do all of those. So I'm going to do 4 of them with you, maybe 3 of them with you, and have you do the others. So let's look at number 1. So for number 1, as I said before, the more times you write down the formula, the more likely you are to do what? Remember it. So since we're doing area for number 1, we're going to write down area equals pi r squared. And then we are using substitution parentheses for anything that we sub into. We've entered the wonderful world of 5,000 formulas. Okay, so don't get lazy. So then we're going to plug in equals pi times, in parentheses, we're going to plug in this. Well, what does the 12 represent? Is it a diameter? Is it a radius? What is it? That's a radius. So that's what we want. So we're going to put 12 meters in here. That's actually a 12. And then we're going to perform the math. Now, they didn't tell us how they wanted the answer. They didn't tell us if they want the answer in exact form or in approximation. When pi is in your answer, that's considered an exact answer. When we multiply pi through, that's your rounded answer. And the question is, what do we use for pi? Do we use 3.14? Do we use 22 sevenths? I hate 22 sevenths, by the way. 22 sevenths is not that decimal up there that's on my wall. 22 sevenths only goes out to 3.14, and then it's all different. So I don't like 22 sevenths. Don't ever use that. Or the pi button on your calculator. Which is the most accurate? The pi button on your calculator. So unless you're told to use 3.14 for pi, you're going to use the pi button on your calculator, always. Okay? And then don't ever round in the middle of a calculation. You can round on paper, but don't round in your calculator. Round at the very end. So here, what's 12 squared? So area is equal to 144. Pi always follows the number 100% of the time, but it comes before a variable. So pi kind of looks like a variable, but it's an actual number. So it's in between a number and a variable if you want to think of it that way. So you got 144 pi, and then what's the meter squared? Isn't it just meter squared? If you put your units of measure in your formula as you're doing it, it will help you get the correct units of measure. So that's our exact answer. Or if I were to use the pi button on my calculator, I now get a rounded answer with a squiggly equal sign. And so if I round that answer, I get 400. And if you have your handy-dandy calculator with you, you can take it out and work it alongside. I'm going to round to the hundredths. So that's my approximated answer. So you have to pay attention to which one we want. And if I were you, if they don't say anything, just do both. Because you have to state this answer anyway to get to this answer. All right, well, on number 7, we're going to skip to number 7 for area. This time, when I have to find area, I want R in order to plug into here, don't I? Have they given me R? What's this equal? What's that? My diameter. Don't I need my radius? What's the radius? Yeah, so what's half of 58? 2 goes into 5 twice with 1 left over. 2 goes into 18 9 times. So my radius is 29 yards. That's what we're going to plug in. So we get equals pi times 29 yards. So we're just going to square 29. So my exact answer is 29 squared is, I don't know, 29 squared. It's 841 pi, and then yard squared is yard squared. Or my approximated answer, I'm going to multiply that by pi button, and I get 2,642.08 yards squared. Yes. Oh. Yeah, because it said 1 through 4, huh? So we're finding area. Just because I wanted one with a diameter. Thank you. I like to not pay attention to directions sometimes. Okay, so then let's go back here and it's 08, yeah. So then let's come back here and look at question number 2 and number 6 for circumference. I'll stay in the proper ones for that one. So then for number 2, if I'm finding circumference, what are they giving me here? What's the 18 equal to? Is that the radius or is that the diameter? It's the diameter. So remember, I have 2 formulas to use for circumference. If I've been given the diameter, why use the radius one? I'm going to use circumference equals pi d. And that's the easiest one to use, especially if they want the exact answer, because I am substituting in for diameter. Now, notice how diameter follows pi in this one. You're not going to write the answer as circumference equals pi 18 inches. That is like not capitalizing the first word in a sentence. Don't do that. So we are going to go ahead and write this as circumference is equal to, and I'm putting my 18 in first, followed by pi, and my units of measure is inches. So this is my exact answer. Or if I were to multiply 18 by pi, I now have an approximated answer. And so 18 times pi is 56.55. And it's just inches. I didn't do anything to score those units of measure. So I like it when they give us diameter for circumference. It's an easy problem. However, look at number 6. What have they given you here? What's the 15.6? Radius. So for this one, I want to use circumference is equal to 2 pi r.
Can't you just multiply it?
You could. You definitely could. But you're going to do it here anyway, aren't you? So, either way. So I'm going to substitute in 2 pi times my r, and I get 15.6. And then that's going to run into my parentheses. So 15.6 centimeters. And so if I double the 15.6, my exact answer would be circumference is equal to 31.2 pi and then centimeters. So I did not multiply through by pi, I just took my radius and multiplied it by 2 to get that exact answer. If they want the pi multiplied through, then your answer is going to be an approximation, so we have squiggly equals 98.02 centimeters. So any questions on area and circumference? Are we good? Okay. So let's move on to some word problems, because those tend to give you the most issues. So let's look at the first 2 here. You're to use area and circumference formulas to find the radius or the diameter. Look at what they gave you. So in number 9, it says find the diameter of a circle. So we are finding the diameter. But notice what they gave me. They said with a circumference. So the minute they said circumference, immediately you should be using the circumference formula. But there's 2 circumference formulas. If I'm finding diameter, which circumference formula am I going to use? Pi d. So I'm going to start off with my formula. Circumference is equal to pi times d. You're then going to plug into that formula what they gave you. Since they gave you circumference is 65.97 meters, you're going to put the 65.97 meters on the left equals pi d. Remember, pi is not a variable, it's actually a number. So if I am going to solve for diameter, I'm going to solve for diameter. How do I get it by itself? Because what's happening to pi and d? It's being multiplied. So we are going to divide both sides by pi. And if they wanted the exact answer, this left side right here would be the exact answer. But we're going to assume that they want it estimated. So I'm doing squiggly equals. My pi is canceled on the right, and I've got 65.97 divided by the full pi. Now I get 20.9989, 20.998. If that's rounded to the nearest hundredth, what does the 998 do? 20.998. What happens? Becomes 21.00. So that's one of those weird ones. So we get 21.00. And then notice that I put my units of measure in here. The meters did not cancel out. So my diameter is just 21.00 meters. If you put your units of measure in that formula, you're not going to get the wrong units of measure. So look at number 10. This time they want you to find the radius, and again they gave you circumference. But I'm finding radius this time, so what circumference formula do I want to use? 2 pi r. Now I know I could still use pi d, and then once I get d, divide by 2, but oftentimes you guys forget to do that. So we're going to plug in what they gave us. They gave us a circumference of 21.99 feet equals 2 pi r. I am trying to solve for r. How do I get rid of the 2 pi? Divide by 2 and pi, and divide by 2 and pi. When you put this in your calculator, it is vitally important that you use parentheses around that 2 pi. Because if you just put 21.99 divided by 2 times pi without parentheses, all your calculator is going to do is divide the 21.99 by 2, but it's going to multiply that answer by pi. So you have to have this in parentheses. So 21.99 divided by parentheses 2 pi, 2 times pi. I get 4r approximately 3.50, and then feet. And that answered the question. So you good with that? All right, so you get a little bit harder. Next page. So 11 says find the radius of a circle with a circumference of 35 pi yards. So this time they give you the circumference in its exact form, in pi. So we're still finding the radius, and they've given us circumference. So if I'm finding radius and they're giving us circumference, what formula am I going to use? Yeah, so circumference is equal to 2 pi r. So I'm going to plug in for circumference 35 pi, and then don't forget your units of measure, yards, equals 2 pi r. I am trying to solve for r. What do? Divide by 2 pi, but a fun thing happens this time. When you divide by 2 pi, the 2's and the pi's cancel on the right. What happens on the left? The pi's cancel. So what's 35 divided by 2? Yeah, so the radius is exactly equal to 17.5, because I'm not rounding on this one. It is exact. 17.5 yards. So don't let that pi bother you. So on 12, this time you were still finding the radius, but this time we have an area. So we haven't done the area yet. So we're finding the radius, but this time they gave us area. Isn't there only one formula for area? So we're going to use area equals pi r squared. They gave us area, so plug in for that, 380.13, and it is important you put in that squared inches, equals pi r squared. So this is going to be step 1. I want to solve for r, so I want to get the r squared by itself. How are we going to get rid of pi? We're going to divide by pi to both sides. So here's the important thing you need to remember. When we divide by pi, because there's multiple steps to this, because this is just going to give us r squared, correct? We're going to get r squared equals some number. So I'm going to take in my calculator, and if you have yours with you, put in your calculator, 380.13 divided by, and use your pi button on your calculator. Don't you get a long decimal, 120.999137, right? keep that long decimal in your calculator. Never, ever, ever round in the middle of your problem. However, we want to round on paper because we want to show our inner work. So on my paper, I'm just going to write 120.999 inches squared. We solve for r squared. What am I trying to find? R, radius. So how do I find r when I have r squared? So we're going to take the square root. Mind you, we rounded on our paper, but our calculator still has the full decimal in there. So depending on your calculator, you're either going to do, you're just going to hit the square root button. Or if you have like a graphing calculator or one that acts like one, you're going to do second square root. So find your square root button and then do second answer to put the whole decimal in there. And you get 10.9999. What does that round to the hundredths place to? Yeah, 11 point, so R is approximately equal to 11.00. And what's the square root of inches squared? Square root of inches squared is just inches. So here we found our radius. So that's a little bit more difficult, right? Okay. Then look at 13. So 13, this time we're finding the diameter given an area. So this one requires even more work. Because area has what in it? What's the area formula have in it? So we're finding diameter, and they gave us area. What's in that area formula? Radius. So we're going to do the same thing we just did on the last problem, but we have an extra step. So we still have step 1. Use your area formula. Area equals pi r squared. Plug in what you know. So 615.75, that's a 7, squared centimeters is equal to pi r squared. How are you going to get r squared by itself? Divide by pi. So our pi's on the right cancel, and we get r squared equals. Now again, you're going to divide that decimal, 615.75, divided by pi, the whole pi button, and you get this long decimal again, 195.9993124. And we still have centimeters squared. I'm rounding on paper, but what am I doing to my calculator as I try to knock my drink over? What am I doing to my calculator? Keeping the whole decimal in here, okay? Because if you round in the middle of your calculation, you're going to have rounding errors, and your answers are going to be a tenth to a hundredth off or more from mine. All right, so then what do we do to solve for r? Square root of both sides. And so then step 2, we're going to get, so find the square root of that 195, the whole big decimal, and I get 13.99999. So again, I want to leave the full big decimal in my calculator. Don't round in the calculator. But on paper, I'm just going to put 13.9999. So R is equal to 13.9999. What's centimeters squared square root of? Centimeters. Then finally, if I'm going to find my diameter, what do? Multiply by 2. So you're going to double it, multiply by 2, and we get 27.99999. What's that? 28.00 centimeters. So we didn't get to question 15, which I really wanted to, but I'll add that onto the movie, and you can watch that last part of it if you want to, and then the video will be online for you. Okay, if you're finding the area of a circle with a circumference of 26 pi feet, start with circumference. So step 1, circumference is equal to an area I want radius, so I'm going to use 2 pi r. So then plug in what they gave you, 26 pi feet equals 2 pi r. I want to solve for r, so divide by 2 pi to both sides. Your 2's and pi's cancel, and your pi's on the left cancel. You get a radius of 13 feet. So then step 2, use that radius to find the area. So your area is pi r squared, and that equals pi times 13 feet squared. So your exact area is 169 pi feet squared, or your rounded area would be 150, or no, I just said that wrong. Or your area is going to be 530.93 feet squared.